Good morning, or afternoon, or evening, depending on when it is you are. In my last Physics 20 class, I gave a quick kind of surprise quiz with 3 kinematics questions. And I told the students that I would be posting solutions, so that's what this is. There were 2 versions to the quiz, so I'm just putting the correct answers in red there, and then I'm going to go through how to calculate them. We can make a list here. The initial speed is what we're after. Now, keep in mind if you're watching this video, whether you're a student of mine or somebody else, at this point in the course when they wrote the quiz, they didn't need to worry about vectors. There was no directional changes in any of these problems. I am putting a vector symbol anyway, but it doesn't really matter. So VI is what they're after. VF is 35 meters per second. And the time is 2.5 seconds. And we also know the acceleration is 6 meters per second squared. And by the way, I've highlighted number 1 up here on the left because this is the version of the quiz that I'm going to solve number 1 for. If you had a different version, you had the version that's on the right, then you're going to do the same thing I'm doing, but you're using a different number in one particular place. Your equation is acceleration equals VF minus VI over t. And some of you made a mistake on this question in that you rearranged it incorrectly. And what I would prefer to do, and I think you'll be more successful, is if you put the numbers in first, I think there's more mistakes to be made with rearranging. Instead, let's rearrange it first. I'm going to multiply both sides of this equation by time. So I get acceleration times time equals VF minus VI. I want to determine the value of VI. And my way of thinking here in terms of the mathematics of it is that VI is negative, and I don't want to know what negative VI is. So I'm going to add VI to both sides, where I get VI equals VF minus AT. And in my solutions to the quiz that I'm posting here, I'm not going to write the numbers in. I'm simply going to grab my calculator and take VF minus AT to get an answer. So if you had the version of the quiz on the left, what you're going to end up with is 35 minus A, which is 6, times T, which is 2.5. You get 20 meters per second. You get this answer. All right? I'm not going to write anything down for this, but if you had the version over here, the only thing that's different is it's an acceleration of 5 meters per second squared. So this 6 becomes a 5. It's still VF minus AT, and you get 22.5. And I've got 23 up here. I told you this when you were writing the quiz. I didn't care about significant figures. If you put 22.5, that's fine. So let's take a look at number 2. This time I'm going to do the second version for number 2. Let's make a list of what we know. Now, keep something in mind here. When you did this quiz, you didn't have to worry about vectors. So I'm going to do it without vectors first, and then I will probably do it with vectors to demonstrate that it doesn't matter. The reason why we can get away without using vectors here is there's no directional change. The magnitude of the acceleration is 9.81. The distance traveled is 6 meters. What are we asked? Oh, also VI is 0. We're asked for the speed that the ball hits the floor at. Well, we can use this formula. VF squared equals 2AD. It's actually VF squared equals VI squared plus 2AD, but VI is 0. So what are we going to get? We're going to get VF is the square root of 2AD. Okay, so before I get to the discussion about vectors, because by the time you're watching this, you will have learned the proper way to do these questions is to include vectors. But before we do that, just go with stepping into a time machine, going back to before you knew these things could be positive or negative in the formula. I take 2 times 9.81 times d, which is 6, and I take the square root of the answer. I take the square root of the answer and get 11 meters per second. Okay? And if I do that with the version on the left, the only thing that would be different is instead of being times 6, it would be times 5. I would still take the square root, and this time I get 9.9. Now, you should know that I've instructed you after the next lesson, which you will have had when you're watching this video. You should know that these things are actually vectors. So we really have vector symbols above here. This is actually a vector, and this is actually a vector. And A is actually a negative number, and D, the displacement, would actually be negative. This would be negative, and this would be negative. But you can see that the negative times the negative will still give you a positive, so you get the same answer. This is a case where you don't have to use vectors, but again, as the next lesson illustrates, you probably should use them all the time. And finally, example or question number 3, a race car accelerates uniformly from, I'm going to do the one on the left this time, 25 kilometers per hour. What's the final speed if it travels 200 meters in 12 seconds? So what do we know? We know VI is whatever 25 kilometers per hour in meters per second is. 6.94, repeating. The time is 12 seconds, and the distance is 200 meters. We're trying to find VF. The formula you're going to use would be D equals VF plus VI. A couple of you on the quiz put a minus here. I know why you're tempted to do that, because it's VF minus VI elsewhere, but it's plus. And this is over 2, and this is times T. You know, if you want to rearrange this first, you multiply both sides by 2 and get 2D. 2D then needs to be divided by T. This is equal to VF plus VI. The final speed will be equal to 2D over T minus VI. And I can go ahead and just finish this off. Might as well. It'll only take a second. So 2 times 200 over T, that's going to be 400 over T, divided by the 12. And then I need to subtract my 6.94 repeating. And that's about 26 meters per second. And if you convert it back to kilometers per hour by multiplying by 3.6, you will have it. The difference over here is that the distance in number 3 for the second version is only 100, so 2 times 100 divided by the 12, and then subtract this 6.94 repeating is only 9.7 meters per second. And if you convert that to kilometers per hour, you're going to get 35 kilometers per hour. So there are the solutions to the quiz. I hope that for those of you that needed help with some of the quiz questions, that is helpful. Remember, I don't normally give rewrites for quizzes, but this is important enough that if you are unsatisfied with your quiz mark, then you're going to show up in my classroom Monday at lunch, and I'll have something for you to write, for you to prove to me that you do know how to do this. In the meantime, I hope that's helpful. Have a fantastic rest of the weekend, and I look forward to seeing you on Monday. Take it easy.